Hi everyone, welcome back to Intermediate Micro, and today we're starting our chapter on information economics. This is a really cool chapter because you already know all of micro. And what we get to do now is take those tools and concepts you know and apply them in some really interesting ways that might push back on some of our standard models of perfect information. This chapter has some math to it, but it's my aim to really teach it to you all more from a conceptual standpoint, so you can start to question things qualitatively instead of just running through all the numbers. We'll start by talking about quality uncertainty, which is a form of asymmetric information. So what do we mean by asymmetric? We mean that the two sides of the market, buyers and sellers, have different knowledge about the underlying transaction. And the canonical example here is used cars. Used cars sell for much less money than new cars, in part because there's asymmetric information about their quality. The seller of the used car knows more about that car than the prospective buyer does. And as a result, the prospective buyer is suspicious of the quality. Why is this used car even on the market in the first place? And let's be clear here. We think that that prospective buyer who is suspicious has good reason to be. Let's explore this example a little further. Suppose we have two kinds of used cars. There's good cars and bad cars. And in a world where there's perfect information, where there's quality certainty, buyers and sellers both know which cars are good and which cars are bad. But that's not true. In the naturally occurring world, we don't have quality certainty over these used cars. And like I said on the last slide, the seller knows much more about the quality than the buyer does. So take a minute to put yourself in the shoes of the buyer. You don't know anything about the car in front of you, but you do know that there are good cars on the market and bad cars on the market. So without any additional information, you might take a guess that the car in front of you is somewhere in between the two. It's a medium quality car. In other words, you might put equal weight on the chance that there's a bad car in front of you or a good car in front of you. As a result, you're not willing to pay the price of a good car because you're assuming this is a medium car. There's a chance this is a bad car. When that happens, better and better cars will drop out of the market. I, as a seller, am not going to sell you a good car for a medium quality price. And when we aggregate that up to the market, I'm not selling you a good car for a medium quality price. More and more buyers start to put more and more weight on the chances that the car in front of them is a bad car. A lemon, in other words. And as that happens, aggregating up to the market, more and more good quality cars drop out of the market. Eventually, only bad cars are left on these used car slots. And the situation I just described, and I'll put it in yellow ink, is known as the lemons problem, where when we have asymmetric information, low quality goods drive high quality goods out of the marketplace. Again, I really want to make sure you understand this conceptually, and the math is only here to formalize our thought process. So if that was unclear to you at all, take a minute to go back and rewatch the past slide. But let's see this on the graph. So let's start by assuming we have perfect information where we have two markets. We have a market for good cars and a market for bad cars. And we have a supply of good cars and a demand for good cars and a supply of bad cars and a demand for bad cars. And each of those markets might be in equilibrium. So if we have perfect information, we might sell 50,000 good cars at a price of $10,000. We might sell 50,000 bad cars at a price of $5,000. So what happens when we don't have perfect information? Well, like I said, you might think of any car in front of you as a medium car, equal chance that it's good or bad. So what does that do on our demand curve? Instead of looking at the high quality car as a high quality car, our demand shifts in because we think it's a medium quality car. So we're going to sell fewer cars at a lower price. I only showed that happening in the good car market, but the same thing happens in the bad car market, where we might sell more bad cars at a higher price, because all we know is that the car in front of us looks like a medium car. So again, even though we don't know what the car in front of us is, there are still these two markets. And in the good car market, we're selling less good cars, fewer good cars at a lower price. And in the bad car market, we're selling more bad cars at a higher price. The quantity of high quality cars is falling, and the quantity of low quality cars is rising. As a result, we as the consumer, the next time we buy a used car, are going to update our priors. When we look at that car in front of us, we don't know if it's good or bad, but rather than put, say, 50-50 odds on it, we're going to think there's a lot more bad cars in the market. Because what just happened is more bad cars sold and fewer good cars sold. So now when we see a car in front of us, rather than think it's medium, we might think it's low medium. This demand curve here and this demand curve here. And as we iterate that process, fewer and fewer good cars get sold, more and more bad cars get sold, and eventually all the good cars drop out of the market, and we're just on our original demand curve of demand for low quality cars. To think about this conceptually, what this means is when we have a market with asymmetric information, in particular with quality uncertainty, we might have a market failure, where price is no longer a meaningful signal, and the good thing, the thing that we want, in this case, a nice car that doesn't break down, is driven out of the market. This market failure arises because the people who value their high quality car don't want to sell it at a low quality price, even though they might want to sell their car in general. So we have gains from trade that could be reaped. We have surplus that could benefit us all that isn't realized. The term for this kind of market failure is called adverse selection. And it's when products of different qualities are sold at a single price because of this asymmetric information. And as a result, you have too much of the low quality product and not enough of the high quality product. Keep in mind that when we talk about buyers and sellers in a market, we can be talking about buyers and sellers in a way that might be a little more subtle than at first glance. For instance, in the labor market, you guys are the sellers, not the buyers. So let's talk about two marketplaces that we might think have adverse selection. Marketplaces where there are different qualities of the product. And in the insurance market, the quality of the product or the quality of the information comes from you. You know how healthy you are. So people who buy insurance, in general, know much more about their health than the insurance company. So why might this be a case of adverse selection? Well, who's going to want health insurance? Obviously everybody, but keep in mind we're thinking about very abstract terms the way economists do. Unhealthy people would demand this more. So as a result, the proportion of unhealthy people in the pool of insured people is going to go up, forcing the price of insurance to go up. As a result, people who are relatively healthy are going to buy less insurance, and then the process, just like in the market for cars, iterates on itself, where eventually you have a pool of very unhealthy people seeking insurance. As a result, you have rising healthcare costs. which we tend to think of as bad. On your own, think of a policy solution for this. So one thing we might do is to pool the risks, make it less risky for people to be insured, perhaps by providing insurance for more people. The government already does this with Medicare, where everyone over the age of 65 is insured. We see something similar in the market for credit. So to talk about this, let's revisit what the credit market is, where it's borrowers asking for money with the promise that they will repay the loan with some interest. Why might there be adverse selection here? Why might there be quality uncertainty here? Because the borrowers have better information about whether and if they will repay the loan than the lender does. And so we have another version of the lemons problem, where low-quality borrowers are much more likely than high-quality borrowers to want credit, forcing the interest rate up. So how might we solve the lemons problem in this example? Well, we can do it in two ways. One, we can try and pool risks like we do with insurance. How do we get high-quality borrowers into the pool of credit? By offering them perks like a platinum card. How else might we solve the adverse selection problem? Well, banks will look up your credit history. And that will help us distinguish low-quality borrowers from high-quality borrowers. Without credit reports, it would be really hard to borrow money. Put differently, there are ways that we can get around this quality uncertainty problem. For instance, with reputation and standardization. So asymmetric information is present in lots of markets, but as buyers and sellers, we've overcome that in a lot of ways. With things like certificates of authenticity in the case of collectors, or standardization in the case of one McDonald's looks like the next McDonald's, group reviews in the case of roofers and plumbers and electricians, the government instituting healthcare laws, or health code laws, I should say, in the case of restaurants. Sellers of high quality goods have incentive to build a reputation, and sellers of lots of goods have an incentive to standardize their product. In other words, we have resolved lots of uncertainty regarding the quality of outstanding products, and these markets function as if we have perfect information. One other way in which we can overcome quality uncertainty is by signaling. And signaling is the process by which we can send information that conveys quality. And so for our purposes, we tend to think of this as a costly process. Let's consider that market for used cars we were just talking about. What's one way that you can signal your used car is of a higher quality? You can get a Carfax report showing its history and damages. To do that is going to cost some money. If you just put a sign on the car that says, this is a really good car, you might be attempting to signal that some valuable information, but anyone can put a sign on their car that says this is a really good car. In econ, we'd like to think of this as cheap talk. It's a signal that's not costly, and thus it doesn't convey much good information. What's a way to convey information in the labor market? Your education. More productive people are more likely to attain high levels of education in order to signal to future employers that they are good workers. We'll quickly model this out, but remember, I really want you to think through this conceptually, and the math is only there to guide you and to formalize the process. So let's, as a quick model, think about two types of workers, Group 1 and Group 2. Group 1 are low productivity, they're not very good workers. Group 2 are high productivity, they're very good workers. low productivity workers have a smaller marginal product of their labor. When you add a high productivity worker, you're going to get more production as a result. High productivity workers have a higher marginal product of labor. So suppose this firm that has two types of workers, low workers and high workers, sells their product for some amount, $10,000, and thinks when we hire a new employee, we'll get about 10 years from that. And for simplicity's sake, we'll say half the workers are low productivity, half the workers are high productivity. So from there, the average marginal product of the workers is 1.5. And remember that marginal product of labor is a good way to set the wage. So if you could identify who was in group 1 and who was in group 2, then you would pay the low productivity workers $10,000 a year and the high productivity workers $20,000 a year. We don't have, up to this point, good information on quality, so instead the employer is going to offer $15,000 a year as an average wage. What this means is low productivity people are earning more than they're worth, and high productivity people are earning less than their worth. Take a minute to read through this slide on your own just so you have the sense of that model all in your head. So because previously employers couldn't determine quality, we want some costly signal. We want education to demonstrate what kind of worker you are. And the thing that brings this model together is it's harder for low productivity workers to attain a high education level. In other words, when you're low productivity, education is more costly. We can think of this cost conceptually, like you might have to spend more time working on your homework, you might have to spend more hours in the library, taking on special tutoring, going to the ARC. Or we can think of this cost literally in that you might be spending more on tuition dollars because you take longer to complete your education. Either way, the identifying assumption in this model is that the cost of education is higher for the low productivity workers. The cool thing here is we're not saying anything about the value added to education. We're just talking about it as a signal, as its ability to demonstrate that you're a high productivity worker. So how do we find the equilibrium in the model? Well, let's say that a firm can't tell whether you're a good or bad worker, but they can see how much education you get. So anyone with some education level greater than or equal to Y star, and Y star might be years of education, is going to get the high productivity wage. If you have less than Y star, you'll get the low productivity wage. We want to know what this Y star is. We want to determine the decision rule. In other words, how much education will high productivity people get and how much education will low productivity get. Keeping in mind that education doesn't make you better, it just acts as a signal. So the only benefit to the education is the fact that you get a higher wage. So education can be useful for signaling your productivity. Let's see. Group 1, the low productivity group, they have a much more costly education. It's much harder to complete your college education when you're low productivity. So though the cost of years of college just goes up at this linear rate, but we'll note that for them, the benefit never exceeds the cost. And remember that decision rule is people above some Y star get a raise, people below some Y star don't. In this graph, the low productivity people just don't get a college education. They get 0 years because the benefit never exceeds the cost, so we just want to minimize cost. We want to minimize benefit. We want to maximize benefit minus cost. We want to minimize cost. We do this at y equals 0. However, for high productivity people, where the cost of getting an education is lower, either because they spend less time on their homework, they finish college faster, whatever, at y equals 4, the benefit exceeds the cost. Note there's no additional benefit to more education because the firm only pays 2 wages, high and low, so there's no additional benefit to 5 or 6 years of college. So where does benefit minus cost maximize? Here at y star equals 4. This is the biggest possible difference between benefit and cost. The high productivity group, in other words, gets 4 years of education because the gain in earnings is greater than the cost. In other words, when people are deciding whether or not to go to college, they're doing a cost-benefit analysis. And that cost-benefit analysis is get y star years of education if the increase in earnings is at least as big as the cost of education. So as long as y star is bigger than 2.5 years, the low productivity group won't go to college. The high productivity group will, as long as y star is less than 5 years. So if y star, and remember y star is the level set by the firm to distinguish the two groups, if y star is between 2.5 and 5 years of college, we can distinguish between low productivity workers and high productivity workers. What happens if y star is less than 2.5? If y star is less than 2.5, everyone goes to college, and it's not a useful equilibrium. If y star is greater than 5, no one goes to college, and it's not a useful equilibrium. So in this equilibrium that we found, where y star is between 2.5 and 5 years of college, high productivity go to college to signal their productivity. Low productivity don't. Firms know this signal is meaningful and in return offer them a higher wage. We'll finish this chapter with 2 more influential concepts in information economics: moral hazard and the principal agent problem. Now these are, like I've been telling you all semester long, examples where econ has stupid words. So it's really important that you understand the concept because moral hazard doesn't make much sense in the context of a 2020 vernacular. But moral hazard is when a party whose actions are unobserved can affect the probability or magnitude of a payment associated with the event. What does that mean? It means that it's when your roommate's turn to do the chores, you're going to mess up the house more. You are going to change your behavior because you have insurance against an adverse event. So when it's your roommate's turn to do the chores, you make more dirty dishes, you mess up the house more because you're not paying the full cost of that risky behavior. We see this a lot in insurance markets, but we also see it in labor markets because we don't have full monitoring. This is problematic because it means there's a shadow cost to the behavior that the market isn't fully absorbing. So let's keep the example going, you and your roommate splitting chores. It's more costly to eat an extra piece of pizza if you have to do the dishes. But because you're not doing the dishes this week, you're eating more pizza because the cost is artificially lower. This is an example of moral hazard. And we see it in all sorts of markets. The example here on the slide is because you have car insurance, you're probably driving more than you would without that car insurance. the shadow cost is hidden and the cost seems artificially lower. A very specific example of this is the principal agent problem, where when we're not fully able to observe someone, they're going to do their own thing. So if this class were a firm, you would be my workers. We are working together to produce economic knowledge. But I, as the boss of the firm, can't observe you all the time. So rather than producing economic knowledge, you're going to do other things. Check TikTok, check Slack. Things that don't produce additional economic knowledge. But at the end of the day, I'm still giving you your paycheck, in this case a grade. So how can we solve the principal agent problem? Well, one thing we can do is what we do in this class, where your grade depends on your production. But what if you were salaried employees in this class, where by agreeing to take the class, everyone got a B? I still can't observe you perfectly, but if you know you're getting a B no matter what, you're probably not going to study as much. We see this example often in private enterprises where managers of a firm are not owners of a firm. So managers pursue their own best interest rather than focusing on the objective of the firm's owners, who are their stockholders. Managers might want to do things that either get them their next job or get them promoted faster or get more perks for themselves, whereas the stockholders are just concerned about the firm growing in value. How do we solve the principal agent problem here? We need to realign the incentives. So if a manager is paid in stock options, then their incentives are aligned with the owners of the firm, because they want their stock value to go up as much as the stockholders do. I started this chapter by saying I want you guys to think about these things conceptually. So to end this lecture, on your own, think about some principal agent problems, some moral hazard problems that you observe in your everyday life, and we'll talk about them more in class. That's it for this chapter. Have a great winter break, everyone.